Alright, so in this video I want to kind of introduce you to the basics about trig. Now, trig as a class obviously involves far more things, but for trig and geometry, we're going to focus on something called SOHCAHTOA. Now, I'm going to refer back to this probably at the end, if I remember. But if you watch the video on labeling, we know that in right triangles, we have three parts of a triangle. And a little bit different than Pythagorean theorem, but we have the opposite, okay, opposite leg. We have the adjacent leg, and we have the hypotenuse. So the hypotenuse is just like it was with Pythagorean theorem. So those are our three parts. So the first trig ratio we call it a trig ratio, and you'll see why. It's called sine. Okay? Now for us, and for our calculators and all that stuff, we're going to use SIN, but we're still going to say sine. This is the ratio, okay, of the opposite leg to the hypotenuse. So when we're doing problems, we'll mostly just say O over A. Now some of this is not going to make a ton of sense until we get into problems, but sine is the opposite leg over the hypotenuse in a right triangle. Right? Cosine, an abbreviation for that will be COS, is the ratio of the adjacent leg over the hypotenuse. So in shorthand, when we're doing problems, we're going to call that A over H, adjacent leg over hypotenuse. And tangent, which we're going to abbreviate to TAN, and again, those abbreviations are what you'll see on your calculator, is the opposite leg over the adjacent leg. So in shorthand, O over A. Okay? So those are the three trig ratios that we're going to be using. So if we go back here now, see where this is coming from? Sine. Let me use a different color here. Sine is opposite hypotenuse. Cosine is adjacent hypotenuse. And tangent is opposite. I don't know why I put that O there, but and adjacent. So SOHCAHTOA is where that comes from. Okay, so basically, if I took a right triangle, draw one here. If I took a right triangle, okay, here's our right angle. Now remember, we always go back to a reference angle, just like I said in the labeling one. So let's say this is 40 degrees. And then I'll put some numbers in here. Let's say this is 5, 4, and 3, which actually isn't completely accurate. But if this is my reference angle, okay, across from the right angle is my hypotenuse. Across from the reference angle is opposite, or opposite. And the one that's part of the reference angle, or the last one left, is adjacent. So for instance, and instead of calling this 40 degrees, because I kind of messed it up here, I'm going to actually erase this, maybe. And I'm just going to call this angle X for now. Okay, so that's angle X. So I said sine was opposite over hypotenuse, right? So the sine of angle X, well, we said the opposite was 4 and the hypotenuse was 5. So the sine of angle X would be 4 over 5. Cosine is adjacent over hypotenuse. So the cosine of X would be adjacent, which is 3, over the hypotenuse, which is 5. Tangent is opposite over adjacent. So the tangent of X would be, opposite is 4, adjacent is 3, so 4 over 3. Now, That's if my reference angle is x. What about if my reference angle is not x? The reference angle is never going to be the 90-degree angle. But what about if now my reference angle is up here? Okay? What about if that's my reference angle? So now all of these things, opposite, adjacent, hypotenuse, change, except for the hypotenuse. That stays h, because that's still crossing the right angle. But now if my reference angle is y, this is now my opposite leg from that angle, from that reference angle, and this is now my adjacent. So now the sine of y, remember, is opposite over hypotenuse. So the sine of y would be 3 over 5. Cosine of y, remember cosine is adjacent over hypotenuse, so that would be 4 over 5. And the tangent of y, opposite over adjacent, would be 3 over 4. So that's why it's important to pick out your reference angle. So that's the basic rundown. Now this does not involve how to solve them. That'll be in another video. But that should help you hopefully understand them a little bit better.